today is for completing reactions. That's what section 2 is on. And you've done a little bit of this already in section 1, and we did a little bit of this when we did all of our reaction demos, but today we're going to go into more detail on how to predict what exactly it is that's going to form. So, predicting the products of a reaction. To predict the products of a reaction, begin by looking at the reactants. So, we'll see what you've got. Reactants indicate the type of reaction. So, how many you've got, what they look like, are they elements, are they compounds? Use what you know about the types of reactions to predict what will likely happen. So, that's the goal for today, is to just get more practice predicting what is it that's going to form. Alright, so this first example here, even if you can tell just by looking at it, we need to make sure we run through all of our options. We have solid aluminum reacting with solid iodine, I2 gas, solid I2, and it's going to react together. Well, you got two elements reacting, so that's going to affect some of our understanding of what this could possibly be. Is this a synthesis reaction? Maybe, right? Decent chance it's that. Is it a combustion reaction? No, we have no oxygen involved, nothing is combusting there. Is it decomposition? No, we've got elements first of all, and secondly we have two of them, so that's not possible. Is it a replacement reaction? Definitely can't be a replacement. We'd have to have a compound in there somewhere, so we know it must be then a synthesis reaction. Well, then it's just a matter of going to your ion sheet, figuring out what the charges on ions are when they form. Aluminum forms, Al forms a +3 charge, and iodine forms iodide with a -1 charge. Therefore, you end up with the formula AlI3, which is what you're seeing right there. That's how we can predict this is a synthesis reaction. Okay, when we get something like this, we have just one compound to start with. So is this synthesis? Can't be synthesis. We've only got one thing. Is it combustion? Nope. Is it decomposition? Has to be. We've got one reactant, so we know we're forming more than one product. Is this a replacement reaction? Not replacement. So these, whenever you have decomposition reactions, I'm likely going to give you what the products are, or give you a hint as to what the products are, because I can't expect that you know what it is exactly that would form. However, there are some things that typically do form from decomposition reactions. One of those is often water. H2O is a very common thing that forms from decomposition reactions. Sometimes we'll see CO2 forming from it. Some reactions will release N2, some will release oxygen. Okay, there's a lot of things that they'll decompose into, and these are all molecules. These are all covalently bonded things. They tend to be that. It's not to say that they're the only thing, but they tend to dominate things when it comes to our predicting of decomposition reactions. Well, what's this one going to form? This one forms water, H2O. Okay, and depending on the heat released by the reaction, it's liquid or gas, and O2. So this is hydrogen peroxide. You saw this in our reaction demo. So it forms liquid water or steam, water vapor, depending on how much heat that reaction releases, and oxygen gas. Okay, this one is C6H6. That is a liquid called benzene, and it's going to react with oxygen. Is this a synthesis reaction? My first thought looking at this is the O2 is telling you something important here. It's not likely going to be a synthesis reaction. This is more likely going to be a combustion reaction. It's not decomposition because we got more than one thing, and it's not replacement because we're actually going to end up with things getting combined in different ratios with different compounds. So we end up actually, your products, whenever you burn something with carbon and hydrogen in it, you always end up with two products. You're always going to end up with CO2, which is a gas, and you're going to end up with water, which often comes off as a gas because of the heat released by the reaction. Okay, so whenever you're burning something with oxygen, and that something is C6H6, or carbon and hydrogen containing compound, you're going to have carbon and hydrogen combining with the oxygen from the combustion to give you your products here. And down below you can see that balanced. Okay, so looking at this one, I have aluminum plus, this is manganese 2 chloride. So, is this a synthesis reaction? Possibly, but I'll explain why it's not likely going to be that here in just a moment. Is it combustion? Nope, we would need to have oxygen to do that, so it's not that. It's not decomposition. Is it a replacement? We can say maybe, and if it is, it must be a single replacement, right? Because we've got an element and a compound. So why is it not synthesis? Well, in all likelihood, the fact that you're trying to combine a metal into a compound that already contains a metal and that is stable seems unlikely as a choice for what could happen here. Not that it's impossible, it's just unlikely going to be what's going to happen. This is definitely the more likely scenario, that we have a replacement reaction going on. In which case, all you need to do is go back to your table of relative reactivities from the previous section, from section 1, to see, is aluminum higher up than manganese on that chart? Turns out it is, and so in that case, aluminum will replace the manganese, and the manganese will become the element. So down below we see that reaction happening. Okay, this one down here is not balanced, just for the record, but the aluminum comes in, aluminum's got a +3 charge, so it needs 3 chlorines. The manganese comes out, manganese is the element that comes from this. So that is a single replacement reaction. It's just kind of ways you can tell that this is not likely synthesis. Again, you got metal trying to come into an ionic compound, something that's already got a metal ion in it. It's unlikely going to form something else with another positive ion. Okay, and this last one here, we have aluminum chloride, aqueous aluminum chloride, and we add to that lead nitrate, PbNO3(2). Is this a synthesis reaction? Again, unlikely. You've got so much going on here. You've got 2 compounds reacting. It's very unlikely that they are both going to combine together. That would be a lot of stuff happening. Is this combustion? No, we don't have O2 anywhere, so it can't be that. Is it decomposition? Definitely not decomposition. We'd only have one reactant. Is this a replacement reaction? Well, that's kind of our only option left at this point. So if that's the case, it's got to be a replacement reaction. This one's going to be a double replacement reaction. The aluminum is going to come in where the lead is. The lead's going to come over and change places where the aluminum is. You end up with 2 different compounds out of this. Remember, you've got aluminum, Al with a +3 charge, and now you've got nitrate, NO3 with a -1 charge. Okay, those 2 together are going to give you aluminum nitrate. And the other one, okay, when lead comes over, lead's forming a +2 charge in this compound because it's +2 here. Okay, and then the chlorine is also -1, so we end up with PbCl2. So these are the products that we form. You got to make sure you're careful about what they are because of the charges involved, right? The positive and negative charges of the ions. You got to predict the right formula. Well, what forms down below here? You may not know the states of products in double replacements. Okay, you're going to know this in the next section. In section 5.3, you will learn to predict what state of matter the products are going to be. So for instance, how did I know that the aluminum nitrate is aqueous, meaning it's still dissolved in solution, and the lead 2 chloride was a solid? Well, there's a set of rules that you'll get in the next set of notes to help you predict that. But for now, all that I really want you to be able to do for predicting the products of reaction is predict the formulas for these things, which means you're going to need your ion sheet. It's a little bit of review from last semester, so you might have to go back and look at that. All right, and that's it for this section.